Good evening, my dear student. I am Rakesh Chaubey from Sunbeam Sun City, Jai Hind you all. My dear, today I am uploading the last topic you can say because I already uploaded the refracting telescope. Today I am uploading the refracting telescope with the two images, one at LDDV and other at infinity. The question is, define refracting telescope, give its construction, working ray diagram for final image formed at two position, one at the near point, that is at LDDV, and second at the normal adjustment or infinity. Hence, we have to define and derive the expression for their magnifying power also. So my dear, this is the last question of this chapter, and then we will follow with the NCERT numericals. Rest all derivations being done in all my earlier YouTube videos. So now, what is a refracting telescope? My dear, as you all know, simple microscope we have done compound microscope. What is simple microscope, sir? It is a magnifying glass made up of convex lens kept close to eye. I repeat, simple microscope is a magnifying glass of convex lens, small focal length and kept close to eye, right? Compound microscope is an optical device, my dear, which is used to see or magnify the tiny object. Compound microscope is an optical device which is used to magnify the tiny object. Now my dear, here is asked for astronomical refracting telescope. What it is, sir? Sir, it is the optical device which is used to see the distant object, or the object which is heavenly situated, that is heavenly situated objects such as stars, planets, satellite, etc. So my dear, what is telescope? The question is, what is telescope? The telescope is what? Sir, telescope is the optical device which is used to see the distant object, or the object which is heavenly situated, that is heavenly object such as stars, planet and satellite, etc. So now my dear, let's begin with the first refracting telescope. It is an optical device. It is an optical device which is used to see the distant object or heavenly objects such as stars, planet, satellite, etc. So here, my dear, I have completed all the three microscope with what they are. Simple microscope was a magnifying glass. Just it is a magnifying glass of convex lens. They are also of convex lens, but simple microscope has only one convex lens. So it is a magnifying glass of convex lens which is kept close to eye. Compound microscope is an optical device which is used to magnify the tiny objects, and telescope is an optical device which is used to see the distant object or heavenly objects such as stars, planets, satellite, etc. Now let's go to the construction. What is the construction? How will we construct this telescope? My dear, as I told you, like compound microscope, telescope is also made up of two convex lens. So it is made up of two convex lens, and these two convex lens we are mounted coaxially. Again, their center will be coinciding. That is, their center should be on one line of both the convex lens, and they are mounted at the outer end. They are mounted at the outer end of one tube, and that tube is a metallic sliding tube, as we have done in compound, that the objective and the eyepiece lens are mounted coaxially at the outer end of the tubes, right? And that is called length of the tube, mechanical length of the tube, that is distance between objective and eyepiece lens. Remember that. So again, the same concept here also. It consists of two convex lens mounted coaxially. So again, it is also mounted. They are consist of two convex lenses and they are mounted. We have put them on one tube, my dear. So we are mounted coaxially these two lenses at the outer end of sliding metallic tube, sliding metal tube. Believe me, and believe me, there is one concept of this. I will tell you in short moment of time. So it is something like that. For example, this is a metal tube. So the objective, which is have a large aperture, large focal length, and this is say the eyepiece. This is eyepiece and this is objective. And here it is called, my dear, again this is the coaxial. That the center is lie on one same line, that is mounted coaxially. So their center, this is center E and this is center O, and this is called, again here also it is called length of tube, and we call this as mechanical length of tube, my dear, mechanical length of tube. And this is your sliding metal tube. This is your sliding metal tube. So I have taken the sliding metal tube and I have mounted these two lenses, objective and eyepiece, at their end. So I have mounted coaxially at the outer end, at the end of the metal tube. I have mounted these two lenses and they are coaxial. And what is the name of lenses? Objective and eyepiece. And now, my dear, if I ask you what is the distance between objective and eyepiece, so that is called length of tube, that is mechanical length of tube. Same concept was we have done in compound microscope. So again, the mechanical length of the tube from this diagram is very clear that it is a length between objective lens and eyepiece lens. And both these lenses are mounted at the end of the metal tube. Okay. Now, my dear, here is one concept. The people ask that how does the objective of this telescope, or how does the telescope is used to focus on the distant object? How it is helping to focus on a distant object? What we are doing to focus the telescope on the distant object? Please try to understand my question. My question is, what we are doing to focus the telescope on distant object? And my dear, believe me, what we are doing, we are varying the distance. We are varying much. I said this is a sliding metal tube. So I can vary the distance between objective and eyepiece lens, you can say. And by varying this distance between objective and eyepiece lens, my dear, we are focusing the telescope on distant object. And this arrangement is called, my dear, a rack. And this is a very important arrangement, this is called. And believe me, this arrangement is beautiful to understand, because this arrangement is given in the book also. We call this as arrangement as rack and the pinion arrangement. Believe me, rack and pinion arrangement. So my dear, my question is that how the telescope is focused on the distant object. And my dear, this can be done by varying the distance between objective and eyepiece lens. And the entire arrangement is called rack and, as I said, if you remember, rack and, what the arrangement called it? It is called as rack and, come on, fast, rack and pinion arrangement. Remember, rack and pinion arrangement. Okay, so now let's start for this concept here. Here I am writing concept. A telescope is focused on distant object by varying the distance between objective lens and eyepiece lens. This arrangement is called, or not, this with the help of arrangement called with the help of arrangement called rack and pinion arrangement, or with the help of, you can say, with the help of rack and pinion arrangement. This arrangement was given by rack and pinion, my dear. Believe me, this is a very important one and beautiful also. That's always, sir, we are focusing the telescope to the distant object. This can be done by varying the distance between objective and eyepiece lens. आप ऑब्जेक्टिव एंड आईपीस लेंस के डिस्टेंस को जैसे से वैरी करोगे बच्चे, द डिस्टेंस बिटवीन ऑब्जेक्टिव एंड आईपीस लेंस जैसे से वैरी होगा, my dear, we keep focusing the telescope, we focus the telescope to the distant object, and the arrangement is called rack and pinion arrangement. Okay, now my dear, let's go to the next construction part. Now, as I said, it is made up of two convex lens. So now first is objective lens. Objective lens, it is denoted by O. In the diagram, in the ray diagram, it is denoted by O. It is a convex lens, of course it is of convex lens of large focal length. I will write the focal length of objective as FO. So it is a convex lens of large focal length, that is FO, and large aperture. And large aperture. There is a question on this point, that what happened because of objective lens has a large aperture, what it makes us to have, what it gives. So it is a convex lens of large focal length, FO. Its focal length is more than the focal length of eyepiece lens. Large किससे large? Eyepiece से large. Eyepiece का जो focal length है उससे large. So it is a convex lens of large focal length FO and large aperture. Am I clear? Placed कहाँ पे? Placed near the object, or placed to see the distant object. It is placed to see the distant object. I am not writing that. Everybody know it is named as objective, so it is placed to see the distant object. And the one which is named as eyepiece, it is close to your eye. So that's not a big deal, but only the important concept is that, sir, the objective has a large focal length FO and large aperture. Now here is a concept. Here is a concept. Whenever I say concept, that can be a question. So now my first question was, how do we focus the objective to the, how do we focus the telescope to the distant object? How do we focus the telescope to the distant object? Sir, simple, sir, by varying the distance between the objective and eyepiece. As we vary the distance between objective and eyepiece, sir, we can focus it to the distant object. And the arrangement was called as rack and pinion arrangement. Now, second point, my dear, the convex lens, objective lens, which is of convex, no doubt have a very large focal length compared to eyepiece. FO is greater than FE, and it has a large aperture. Now, concept here that what happened if the objective lens has a large aperture? What it will help us? It will help for what? So, my dear, here the concept. The objective lens, yeah, the large aperture of objective lens gathered more or sufficient light. We have done this. Sir, aperture large रहेगा तो it will gather more light or sufficient light from कहाँ से? From the distant object. From the distant object. And it will form the bright image of that distant object. And it help to form a bright image. So जितना ज़्यादा aperture बड़ा होगा, जितना ज़्यादा aperture objective lens का बड़ा होगा, Simple answer, one line answer, sir. It gathered more and more light from the distant object and it forms the bright image of the object. Please. So my dear, the large aperture of objective lens gathered more or sufficient light from distant object and forms bright image of distant object. Simple. So it gathered more and more light from the distant object and helped to form a bright image of distant object. Please. This is the aperture of the objective. If it is large, this is what we have benefited. So remember, my dears, the two concepts I have done. First concept, how the telescope focused to the distant object. So sir, by varying the distance between the objective lens and eyepiece lens, arrangement called rack and pinion arrangement. Second important concept, what happens if the objective has a large aperture. So if the objective lens has a large aperture, it will gather more and sufficient light from the object, from the distant object, and it forms the bright image of that distant object. Am I clear? Second point is about eyepiece lens. Eyepiece lens. Sir, it is a convex lens. Of small focal length, FE. That is, FO is greater than FE. Focal length of objective lens is more than the focal length of eyepiece lens and has small aperture. Focal length is also small and aperture is also small. That's all. So my dear, here this is all about, I have written about what is a refracting telescope, what is its construction. That's all. In this particular part, I have referred only two things. That is, what is refracting telescope and what is construction. So I hope everybody understood. So refracting telescope is an optical device which is used to see the distant object or heavenly objects such as star, planet, satellite, etc. Second point, sir, construction when we are doing, we are taking the two convex lens for telescope, and both these convex lens, my dear, are mounted coaxially at the outer end of the metallic tube, a sliding metal tube. Am I clear, Bachche? Now, the question asked here that how do the telescope focused on the distant object? Suppose the telescope is focused on the distant object by varying the distance. By varying the distance between the objective lens and eyepiece lens, and the arrangement is so called as rack and pinion arrangement. Next question is that, sir, objective lens के बारे में क्या जानते हैं? Objective lens has a convex lens, no doubt, having a large focal length. Focal length large किससे? Compared to eyepiece lens, and it has a large aperture. What happens if the aperture of the objective lens is large? Sir, it will gather more light, sufficient light from the distant object, and it will form a brighter image of the distant object. An eyepiece lens has a small focal length, FE, that is focal length of eyepiece. Am I clear? Which is less than FO, focal length of objective, and it has a small aperture. So that's all, my dear. This is all about refracting telescope and construction. Now let's go for its working ray diagram for two different positions of the images, one at LDDV and the other at infinity. Let us start with the ray diagram for the first case, that is the final image formed at the least distance of distinct vision or near point, that is at capital D. Okay. Now, as you all know that we have to draw objective and we have to draw eyepiece. Sir, objective should be of large focal length, aperture should be large, मतलब वो बड़ा होना चाहिए, and eyepiece should have small focal length, aperture is small, मतलब वो छोटा होना चाहिए in the diagram. In the compound microscope, my dear, objective has a small focal length and eyepiece has a large focal length. So in compound microscope, objective has drawn smaller and eyepiece has drawn bigger. Whereas in telescope, my dear, objective will be drawn bigger and eyepiece will be drawn smaller. Take care, this is a distinguish between compound microscope and telescope also. That the focal length of the objective lens in compound microscope is smaller than the focal length of eyepiece. Whereas in telescope, the focal length of objective is greater than the focal length of eyepiece. So let's start with the diagram here, my dear. Say I have drawn the objective lens. This is your principal axis I have drawn, and here is the optic axis, and this is, I put it as O because objective lens. So here I can put O, and the focal length is FO, that is objective lens. And now my dear, assume karo कि here the ray of light is passing from the optical center, from the distant object the light is coming. It is passing through the optical center. Another light is coming here. So these are the light ray coming from the, I will mark here dotted one. There you can see there is a parallel beam of light. I can write parallel beam of light from distant object falling on the optic axis here at this point and at the optical center of the objective lens. My dear, I can no need to draw objective here. But if you wish, you can draw the objective by here, put the dot, put a gap, and here you can draw the objective. But remember, the objective no need to draw because here the object is actually at infinity. So here I can write AB. Here I can write AB. But my dear, remember here the object is at infinity. So here I have put a gap. You can see. You can see here I put the gap so that the object is at infinity and this parallel beam of light is coming from the distant object. Okay, now my dear, here you all can see, say this ray will be refracted from this parallel beam which is coming here, fall on the objective lens, will be refracted, and say it is going this way. Now here I will draw the another lens. Here is the, my dear, I can see the image formed by the objective. This is the image, say the name of the image is B dash, A dash. And this image is real, inverted and diminished because light is coming from infinity. So the image is real, inverted and diminished, my dear. And this image is formed by objective lens. Take care. This image is formed by the objective lens, my dear. Name of the image is A dash B dash and it is real, inverted, diminished. Right? Now my dear, here when I say, no doubt sir, this is the ray coming here. Since the ray coming from infinity, so you all know the rules, my dear, by the convex lens or by any lens, but if the rays are, if the object is at infinity, the image will be formed at the principal focus. So this image which is formed by the objective lens will form this image at the principal focus of the objective. It will form this image at the principal focus of the objective because light coming from infinity. Very true. We all know from class 10. So now my dear, here let us draw the eyepiece lens now. Now let us draw the eyepiece lens. Here I have drawn the eyepiece lens, my dear. Here say I have drawn the eyepiece lens. This is the your optic axis, and these are the two rays which are falling at this 2 point. You can see one coming from optical center and other coming from refractions takes place here, and it is coming here. You can see, my dear. Now my dear, here this is the center of the eyepiece lens. I will mark this as E, and this is your eyepiece with the focal length FE. Now my dear, to draw the ray diagram, there is small, it's my request, there is small concept which you are supposed to follow. What you are supposed to do, first you draw the ray passing through optical center and this point. Like this. Then you draw the ray from this point. Let me draw and let me show. So one ray I have drawn from the optical center of the eyepiece. You can see like this. One I will draw from here. It will go here. One I will draw from here, my dear, this point you can see. And it will also go here. Here you can place your eye. So nice. And other, my dear, you can see the fourth ray is also coming. And the fourth ray, this image is striking at A dash. It will travel parallel to the principal axis like this. And this will also come here at the back. And everybody will meet at this point. Now here you can draw the dotted lines. Now you make this as a dot lines. Similarly, you can draw this as a dot lines. You can draw this as a dotted lines. You can draw this as a dotted lines. And my dear, here you all can see the image is forming at this point. Here is the image formed. Here this also I will make it as a dotted line. And this is the final real inverted image as compared to object, my dear. With respect to object, this image is real inverted, believe me. And this is called B double dash A double dash. This is a final real inverted image formed by the eyepiece. At what distance this image is formed? So this image is formed at least distant of distinct region. That is at capital D. I hope everybody is clear. Now my dear, there are three concepts. This is the diagram, my dear, for the telescope forming an image at least distance of distinct region. One thing, there are three very important concepts. Look at that concept. My dear, here you all can see that this is the distance from objective lens to the image, first image A dash B dash, which is formed by the objective. Where this image is formed? At the principal focus of the objective, this image formed, because the light rays are coming from infinity. So it will form the image at principal focus of the objective, because objective lens forming this image. So there it will be FO. I hope everybody is clear. And second is important concept is, what is important concept? My dear, this image A dash B dash, which I have obtained, which everybody can see, which is real inverted and diminished image formed by this objective lens. Now my dear, what I will do, I will write this in my working, please, but listen to me. Now what I am going to do, I will adjust the eyepiece. and by adjusting this eyepiece, I will bring this image, which is nothing but the object for eyepiece. This image is the object for eyepiece. I will bring this image A dash B dash, which is object for eyepiece, within the I will brought this image which act as the object for eyepiece. By adjusting eyepiece, I will brought this image A dash B dash within the focal length of eyepiece. Within the focal length of eyepiece, my dear. Take care of that. And that I will write in my explanation also. लिखना चाहिए. So the diagram आपको समझे कि it is within the focal length of eyepiece. And here you can exceed this one. Here this one, my dear, this one you all can see this particular ray going parallel to the principal axis. Then after refraction from eyepiece, it will go through the principal focus. It will go through the principal focus of the eyepiece. I will mark Fe dash. Here I will mark Fe dash. Because after refraction, my dear, it will pass through the principal focus because light are parallel to principal axis. Okay. So I hope you understood. Now the last two things which I supposed to mark. One is, since this is the objective for the eyepiece, A dash B dash become objective for the eyepiece. So I will take this distance from objective, as this is the object from eyepiece, my dear. This A dash B dash become object for eyepiece. Let this object distance is UE. UE, that is object distance for eyepiece, because this image A dash B dash become object for eyepiece. So this become object distance from eyepiece. This is one thing. And next, last one more point, my dear. Here you all can see in my diagram that the parallel beam of light from infinity is falling on the objective lens. And it make, my dear, on the objective lens, this parallel beam of light coming from infinity, it makes a objective angle, visual angle at objective lens. That is, it subtend an angle, my dear, and that angle is alpha because it is subtended by the distant object. It is subtended this angle on the objective lens, my dear, and that angle is alpha. So please take care in this topic. Don't draw this diagram. My dear, this diagram is feasible when object is at least distance of distinct vision. And we are drawing and making this angle alpha because object subtended at LDDV, it can be seen by a normal eye. But now the object is at infinity. It is not at LDDV. So don't make an angle alpha making with LDDV, bache. Angle alpha is made here itself on the objective lens by the distant object, the parallel beam of light falling on the objective lens. So please take care. In the telescope, we don't draw this diagram. This is not feasible for telescope. Because it is simple logic, bache. Give one small minute thought that sir, the object is at infinity, not at least distance of distinct vision. So this diagram is not applicable for telescope. In telescope, the alpha, the angle subtended by the object is alpha is on the objective lens itself. because it is magnifying the object coming from the infinity. So itself the angle alpha is made on the objective lens itself. Please don't do this kind of a mistake, because that's what I wanted to say. Don't read the microscope concept superficial. Here the object is not at least distance of distinct vision, then how you draw the alpha angle for this? The alpha angle is subtended by the distant object, the parallel beam of light falling on the objective lens. I hope everybody clear. So please remember that in the case of telescope, don't ever draw this diagram neither for LDDV case nor for infinity case, because in both the case your parallel beam of light, your object is from infinity. You are observing distant object. So the angle alpha will be directly made on the objective lens itself. And here I am drawing alpha, look at it. Look at the diagram carefully. So here my dear, this will not there included in this concept of telescope. This should not be there in anywhere in the telescope. So now I hope angle alpha, which is made by the parallel beam of light coming from distant object, this angle alpha is subtended on the objective lens. Am I clear? And you all know alpha is angle made by object. So it is the angle alpha which is made by the object, but object is at infinity, and this angle is made on the objective lens. And now my dear, here this is the final image made by the eyepiece. This is a final image drawn by the eyepiece, and therefore my dear, the angle by the eyepiece here I can draw. This is the angle my dear, and here I will mark beta. That is the final angle subtended, that is beta my dear, by the image at the eye with the help of eyepiece. And this is angle alpha is nothing but the angle subtended by the distant object, parallel beam of light falling on the objective lens. This is the important part. Now my dear, by geometry you all can see here, the last one, by geometry you all can see, if here is an alpha, if here is an alpha, then by using geometry I can say this is vertically opposite. So here also I can mark alpha my dear. Here also I can mark alpha. So this is also alpha. That is vertically opposite my dear, the opposite. By geometry you can see. And now I can measure alpha by using triangle A dash B dash O, and I can measure beta using triangle A dash B dash E. I can measure alpha by using triangle A dash B dash O, and I can measure beta because ultimately magnifying power we require only two concepts, beta and alpha. So we can measure beta by A dash B dash E, this triangle, and we will measure alpha by this triangle A dash B dash O. We can measure alpha. So beta and alpha is known, and then we can calculate this. So this is the final diagram my dear, the real diagram, the final one between for the least distance of distinct region. Am I clear? And by diagram also you can see my dear, what is the one small question to you all, what is the length? What is the length of tube? So length of tube here is nothing but a distance between objective and eyepiece, distance between objective and eyepiece. And sir, you can see here to here the distance is FO. From objective to this point the distance is FO, and from eyepiece to this point the distance is UE. You can see. So now length of tube is nothing but FO plus UE is the length of tube in case of LDDV. In case of least distance of distinct vision, diagram से दिखता है बेटा that the length of the tube, that is a distance between objective and eyepiece, is nothing but FO plus UE. FO plus UE is the length of tube, or is the distance between objective lens and eyepiece lens. So now my dear, let's start for its working. So I will write 3-4 points for working, and I will go for magnifying power. Now my dear, let's start for the working, that how this is worked with the things to get a final image. So let's start for the working. The very first point, as you all can see the figure, look at the figure carefully and please help me and cooperate me for writing working. 4-5 crucial point. Remember my dear, in the exam we have a question, right, working. So remember, this working is important, so everybody should aware at least to write 4-5 points here and there with their own way. So my dear, the first point, you all can see the parallel beam of light coming from the distant object falling on the objective lens, making an angle alpha. I am sure you all clear. So how I write this? A parallel beam of light, a parallel beam of light from distant object falls on objective lens. A parallel beam of light from distant object, simple line, falls on objective lens, making an angle alpha, that is angle subtended by object. So this is clear, bachche. The parallel beam of light from distant object is falling on the objective lens. It's falling on the objective lens and it make an angle alpha, my dear. And this angle is the angle subtended by the object. No doubt it is making angle alpha to the lens, so it will make an angle alpha to eye also, because eye close to the lens. So no issues about it. It is angle subtended at the eye only. But my dear, when we make the telescope concept, please don't draw this. This is absolutely wrong, my dear. Here it is alpha, here is your eye, and here is least distant of distinct vision, my dear. Please make sure this is capital D. Here the object is at least distance of distinct vision, and here the concept of object is at infinity. So please don't draw this diagram in the case of telescope. In telescope we are following that our object angle alpha is made on the objective lens itself. I have written this: a parallel beam of light from the distant object falls on objective lens, making an angle alpha. And that angle alpha, everybody know, that is angle subtended by the object. So simple concept, please don't forget this, and don't draw this diagram anywhere in the case of telescope, because my dear, in telescope the object is at infinity, it is not at least distant of distinct vision. So don't do any such mistake, don't confuse yourself. That diagram of the keeping object at LDDV is only for simple microscope and only for compound microscope. It is not for telescope. In telescope, my dear, you all know the object is at infinity. So my dear, it will subtend, this beam of light from infinity, from distant object, will fall on the objective lens, and it will make an angle alpha on the objective lens itself, my dear, and that angle alpha is the angle subtended by the object. I hope it is clear. And by geometry, this alpha is vertically opposite here. I can find this alpha with the geometry, with the triangle case by taking triangle A dash B dash B. So now here, my dear, this is first point, very crucial point. Second point. Now objective lens, after falling this beam of light, when fall on objective lens, what objective lens will do? Objective lens will form its image. A dash B dash is the image formed by the objective lens, and this image you can see with your eye, bachche, with your naked eye, that the image is real, image is inverted, and image is diminished. Believe me, this is diminished image because the object is at infinity. So my dear, here try to understand what I am drawing. You can say here the objective lens. The objective lens O forms real inverted diminished image A dash B dash. Go slowly and cover the thing. First I have written that the beam of light coming from a distant object making angle alpha on the objective lens, fall on the objective lens making an angle alpha. Now objective lens, what it will do? Sir, it will form a real inverted diminished image A dash B dash. Where it form this image? Sir, at its principal focus. At the principal focus of objective it will form the image. Why? Because object is at infinity. So image is at focus. So please write down that line. So the objective lens forms real inverted diminished image A dash B dash. कहाँ पे? At the focal point of objective lens. At the focal point of objective lens named FO. I hope it is clear. This image is obtained कहाँ पे? At the focal point of the objective lens, FO पे. Why sir image is obtained at focal point of objective lens? Because sir object is at infinity. So image is at focal point. This is my point number 2, my dear. Point number 3. The objective lens story is over. Objective lens story is over in 2 points. What is first point? Sir, parallel beam of light from the distant object fall on the objective lens making an angle alpha. That angle alpha is nothing but angle subtended by the object. Second, this objective lens will form the real inverted and diminished image A dash B dash of this parallel beam of light distant objects. It will form its real inverted and diminished image A dash B dash. कहाँ पे? At the focal point of the objective. At the focal point of the objective, this image will be formed by the objective lens. That's all. Now my dear, now this object, this image A dash B dash can see, and it's a normal human being understanding, we have done such concepts. Now this image A dash B dash is now the object. Is now the object for the eyepiece. And I will adjust the eyepiece in such a way that this object, which is acting the object for the eyepiece, will lie within the focal length of eyepiece. Eyepiece को adjust किया so that ये जो object है eyepiece के लिए is lie within the focal length of eyepiece at what distance? At a distance of UE. ये adjust करके लाया मैंने. ये जो इमेज था वो अब ऑब्जेक्ट बन गया आईपीस के लिए एंड नाउ आई एडजस्टेड द आईपीस my dear, and that I'm going to write here. I will adjust the eyepiece so that this object A dash B dash for eyepiece is lie within the focal length of eyepiece at a distance of UE. So my dear, my point number 3, कुछ ऐसे, this image A dash B dash act as a object for eyepiece lens by adjusting eyepiece lens or by adjusting eyepiece A dash B dash brought within the focal length of eyepiece at a distance of UE from eyepiece as shown in figure. So nicely I have written, बच्चे, please make sure you are understanding. Make sure. This is point number 3. That the image A dash B dash now act as, now I can write here, now act as an object for eyepiece lens. By adjusting the eyepiece, A dash B dash, by adjusting eyepiece, A dash B dash brought, this A dash B dash is brought within the focal length of eyepiece, my dear, is brought within the focal length of eyepiece. You can see I brought this, by adjusting this, I brought this A dash B dash within the focal length of eyepiece. At what distance? At a distance of UE from eyepiece. So my dear, this is what the difference between LDDV and the image formed at infinity. When the image formed at infinity by eyepiece, this will be lie at the FE of eyepiece. This A dash B dash will lie at FE of the eyepiece. So nice. I will show that figure also. Only this is the changing in the infinity and LDDV concepts. This is the change. This is the change in concept of image at LDDV and image at infinity. Image at LDDV में बच्चे this A dash B dash is brought within the focal length of eyepiece at a distance of UE, and at infinity case, when the image is at infinity, this A dash B dash will lie on the focal length of eyepiece. That is this distance UE, where here it become FE in the case of infinity. Please. So this is my point number 3, and my last point, that is point number 4, my dear. The point number 4 is the last point of the working. Please take care. This is the last point, I'm sure. Now my dear, as this become the object for the eyepiece, A dash B dash become the object for the eyepiece. So now you all know that this eyepiece will form the final real inverted image. Final real inverted image you can see with respect to object, my dear. With respect to object, this final real inverted image formed by the eyepiece. And what is the name of that final inverted image? A double dash B double dash. At what distance? Capital D from eyepiece. At a distance of near point, or at the least distance of distinct region from the eyepiece. That's all. And that is the last working point. So last point, my dear. Thus, eyepiece forms a final image A double dash B double dash. Thus, eyepiece forms a final image A double dash B double dash, which is real inverted and magnified with respect to the object. यहाँ पे एक चीज लिख दो, कहाँ पे मिल रहा है ये इमेज? So the eyepiece forms a final image A double dash B double dash, which is real inverted and magnified at a least distance of distinct region this I have written in bracket. Now it is continued, which is real inverted and magnified with respect to the object. And this I have written in the bracket, that where the image is formed. The image is formed at a least distance of distinct region, and this image is real, inverted and magnified with respect to the object. So this is, my dear, the 4 crucial points of the working, believe me, and they are very important concepts. This is 4 crucial points. The 4 points, I hope everybody clear. First, the parallel beam of light from distant object fall on the objective lens, making an angle alpha. This angle alpha is nothing but angle subtended by the object. Second point, my dear, this objective lens will form the real inverted and diminished image A dash B dash, where at the focal point of the objective, at the focal length of the objective. Am I clear? Third important point is, my dear, this image A dash B dash is act as the object. this image A dash B dash act as the object for the eyepiece, and I adjust the eyepiece, my dear, such that this image A dash B dash, which is nothing but the object for eyepiece, is brought within the focal length of eyepiece at a distance of UE. And this is what the difference between this image at LDDV and image at infinity. Image at infinity, this is brought at FE. This will brought at FE. Matlab there FO and FE will coincide. In infinity case, FO and FE will coincide by adjusting eyepiece. And now, my dear, the last point, the eyepiece is so adjusted. The eyepiece is forming the final image, my dear, of this object A dash B dash at A double dash B double dash at a distance of capital D. And this final image is real, inverted and magnified with respect to the object. This is the whole crucial point of the working. I hope everybody understood. Now let's go for its magnifying power.